In 1904, an Australian engineer, Mitchell, produced an astonishing piece of work. He basically developed new means of identifying structurally optimal forms. In 1904, this was clearly ahead of its time. There was no obvious practical applications of the work, and effectively it was an academic diversion, or that's how it must have been perceived. And in fact, that work was pretty much forgotten for 50 years. Now, additive manufacturing has changed all that. With an additive manufacturing process, it's no more expensive to fabricate a complex component than a simple one. So all of a sudden, it brings the whole field of structural optimization to life. What this process does is it finds the best topology for a given loading configuration. And in some cases, you can reduce weight by 20, 30, perhaps even 50% compared with a conventional component. So what we have here is a very simple design problem. It's a cantilever or a bracket of the sort that we see in many places around us, and also are used, for example, on aeroplanes, for door hinges, for supporting overhead luggage and so forth. And over a 30-year lifetime of an aircraft, carrying 1 kilogram is equivalent to $100,000 of aviation fuel. If you can save tens, hundreds of kilograms, then clearly you've got major savings. The key is to keep the load carrying performance but reduce the weight. And to do that, we are exploring radically different topologies. So here what we have then is we found the topology for our bracket. What I can do is show the mode of deformation of that structure, and I can look at exactly what the form of that structure is. It's complicated, but with additive manufacturing techniques, there's no problem. Okay, so once we've produced the optimal topology, it's in a position that it can be converted into layers that can then be passed to the machine in order to fabricate the component.
Okay, so here we are, a few hours later. We're going to open the machine to see what we've got. And here's the finished part.
Okay, so from the computer screen to a physical object in the space of a few hours. And you can see that it's an exact replica of what we can see on the screen. Until very recently, clearly, that simply wouldn't have been possible. So for all sorts of applications, components are now quite commonly manufactured using additive techniques. So I feel a bit sorry for Mitchell back in 1904, who had amazing ideas, but whose ideas were effectively before his time. And I feel very privileged that in 2012 we can actually realise some of these mathematically intriguing structures and go about understanding exactly how they work physically.